In this video, I'm planning to explain to use the division inequality here, all the terms with z, so we can use division method. But here in the second question, if we can see here, z minus 3 plus 8i is equal to z conjugate. First, we should understand this difference. If the terms are same or like terms, we can use the division for the equality. But if the terms are different, like these are, z and z conjugate, we cannot use division method. So if we cannot use division method for z, for the second one, or the question number 19, we should use x plus yi method. What I mean, if z is equal to x plus yi, z conjugate, it should be equal to x minus yi. So we should replace these values in the equation. X plus yi minus 3 plus 8i is equal to x minus yi times 1 plus I. It's going to be. For finding the value of the z, you should find x and y one by one. So x plus yi minus 3 plus 8i equals to, here multiplication, x plus xi minus yi minus yi square, it's going to be. So the terms with x and y one side, the terms without x on the other side, x and y. First, we need to remember I square is equal to minus 1. That's why this expression is going to be plus y. When you send to the other side, it's going to be minus I again. X plus y I minus x. This goes to the other side, becomes minus I. Minus xi plus yi normally it is, and this should be plus yi square, but we have minus 1, that's why it's going to be minus y equals to 3 minus 8i. Here we can easily see x and minus x, we can simplify. We can leave the terms yi xi yi minus y, so minus y is without I term, that's why it's real part, and I'm writing first that one. Then yi plus yi is equal to plus 2yi, and minus, here it's going to be xi equals to 3 minus 8i. If we continue to this operation here, we need to get I bracket here, parenthesis, minus y plus 2y minus x. When you get the I out of the expression, it should be 2y minus x, and here it's going to be equal to 3 minus 8i. So real part, it should be equal to real part. Real part, it should be equal to real part, and imaginary part, it should be equal to imaginary part. So minus y equals to 3, minus y equals to 3, and 2y minus x equals to minus 8. Y should be equals to minus 3, and if y is equal to minus 3, we will substitute here, and 2 times minus 3, we will substitute y by minus 3, minus x is equal to minus 8. It's going to be minus 6 minus x is equal to minus 8, and minus x is going to be equal to here minus 8 plus 6, and minus x is equal to minus 2, x is equal to 2. So we understood this one. X equals to 2, y is equal to minus 3, that's why z is equal to x plus yi is equal to 2 minus 3i. For this question, we don't have another method like this one. Here we should replace z by x plus yi and this one by x minus yi. But for the second question, or the 21st question, we have different solution methods. There is no need to substitute z by x plus y. Directly we may use the z. Z plus 3i, or if we directly multiply here, z times I, zi, 3i times, it's going to be 3, z times minus 2, sorry, should continue one by one. Z times minus 2 is equal to minus 2z. 3i times I is equal to 3i squared. 3i times minus 2 is equal to minus 6i. 2z times I is equal to 2zi. 2z times 2 is equal to plus 4z. 1 times I equals to I, and 1 times 2 equals to 2. It's going to be the terms, like terms, I mean z, to one side, the others on the other side it's going to be, but we need to remember this one. This expression is going to be equal to minus 3. So when you send to other side, it should be plus 3. Zi minus 2z is equal, 2z, and minus 2zi, and this 4z when we send to other side, it's going to be minus 4z, is going to be equal to, here this 3i squared becomes minus 3, and when you send to other side it's going to be equal to 3, and minus 6i when you send to other side it's equal to plus 6i, plus i, and plus 2. So the terms with I in this part I'm going to collect to one side and the others on the other side, and minus 2z minus 4z is equal to minus 6z, and zi minus 2zi is going to be minus z I, 2 minus z, 2 minus 1 is equal to, and here it's going to be on the other side, 5 plus 3 plus 2 is equal to 5, and 6i plus I is equal to 7i is going to be. Okay, now this, in this part the z is common term. If it is common term, expression will be, when you get the z here, you leave 6 minus I, it should be, is equal to 5 plus 7i is going to be. So z is equal to, when you send this one to the other side, it should be in, it should go to the denominator, z plus 5 plus 7i over minus 6 minus I. After this part, we have to make division for finding the z. Here, minus 6 minus I, we have to multiply by the conjugate of it. Here, this is the first part and the second part of this one. Z is equal to 5 plus 7i over minus 6 minus I, and here we should multiply by minus 6 plus I. This is the conjugate of it. and we should multiply the denominator by the conjugate. If you are multiplying the denominator by conjugate, you should multiply not to change the function value, not function. 5 plus 7i times minus 6 plus I over minus 6 minus I times minus 6 plus I. This is going to be equal to, we have to multiply one by one each term here. 5 times minus 6 is equal to minus 30. 5 times I is equal to plus 5i. 7i times minus 6 is equal to minus 42i. 7i times plus I is equal to plus 7i squared. It's going to be. Here again, I'm going to repeat the same thing. Multiplication of two conjugate numbers is equal to square of the sum of the coefficients. So minus 6 square plus, here the coefficient is 1, so it's equal to 1 square. The result is going to be here minus 30, and this expression, it should be equal to minus 1. So minus 30 minus 42 plus 5 is equal to minus 37i, and here 7i squared becomes minus 7 over, here this is going to be 36 and this is going to be 1, and minus 30 minus 7 is equal to minus 37 minus 37i over 37. If we separate this one, here this is equal to z, of course. If we separate them, z is equal to minus 37 over 37 minus 37 over 37i, it should be. This is the standard form of a complex number, and it should be equal to minus 1 over minus I. 37 and 37, if we simplify, we are going to find these numbers. Okay.